thank you so much for inviting me. I really appreciate it. I do love art. I get overly excited, so please let me know. I'm gonna start giving you first a very quick intro of where things are and where the materials are. So you're gonna find something like this, and there's a lot of resources and a quick intro of what the workshop is. You can go ahead and here in the code section, if you don't use GitHub on your desktop already, you can just go ahead and download it as a zip, and it will download the entire folder, and it will look something like this once you download it. It will look, yeah, so we'll have the 3 files, the README, the license, and the slides, and then slides is where all my material is going to be, or is already. So each one of these, at the end, it says a slide. That means I'm going to go over that. And if it says examples, that's where I'm going to walk you through live coding and examples. And I also added some solutions for the 2 main exercises break times that I'm going to have for you all. So if at any point you get too frustrated, you ask us questions, if you're still frustrated, the solutions are always there, so you can go ahead and pick up them. And at the end, I have a little bit more of the slides, but the data set that we have is right here, so you don't have to download a data set from anywhere. So once you download this folder entirely from GitHub, you will have access to all the things that you need for the workshop. So if you haven't done it already, make sure to do that right now while everything is happening. Okay, so let's go back to my slides. Let me move some things around. I have my slides both in HTML, like here right now, and I also have them in PDF format. So if you prefer to see the PDF format, that's also in the folders. I just want to give a shout out and a thank you to David Kite and Daniel Navarro and Paul Campbell for all their help and open resources. So some of the materials I have and some of the slide formatting have been coming from them, and they're wonderful resources. Thank you so much for inviting me, and welcome to the workshop. So the agenda for today will be to go into very quick introduction to R and R Studio, what it looks like. Then I'm going to go over what RMarkdowns are and a quick introduction to RMarkdown, including an exercise. Then we're going to dive into data wrangling, and that's most of the exercises I'm going to have. We're going to put you in breakout rooms, and you're going to work on the exercises that we have there. I'm going to go over data visualization. Sadly, we don't have 6 hours to spend on R, so we are going to go very quickly into data visualization and how you can make basic graphs and make basic modifications to a graph. But hopefully in the future, we will have a workshop that goes more in depth on how you can manipulate your data to make graphs in a way that you would really like them to look like. Okay, if you are stuck, make sure to ask your partners. We're going to put you in breakout rooms, and you're going to have in there, make sure to know each other, get to know each other, your names. Maybe you can troubleshoot through your problems together. We do have a wonderful team of TAs that will be walking around the different breakout rooms to help you if you get stuck. But like I said already, we do also have the solutions in there if you don't want to ask anyone. If you're still stuck, make sure to raise your hand. If you have any questions or anything, make sure to use the reaction button emoji thing in the Zoom for us to get to you, and you can ask any questions. You can feel free to interrupt me at the point if you have a question just by raising the hand, or you can go ahead and put in the chat the questions, and our wonderful TAs will be able to answer them for you, to you. Okay, let's dive in. Let's go over intro to R and importing data sets. So as many of you have done already, it was shared with you this week. you need to download and install R and RStudio. So those are two different things that you need to download into your computer to make everything work. You can technically code everything in R. One, it looks terribly ugly. It's very hard to see what you're doing. And it's just like discouraging. So you need RStudio to make those things. Of course, you can use other softwares to run R, but so far the most famous and the most used one is RStudio that help you do anything with the R language in the background. And it's free. So that's something, it's very important. So a very quick tour of RStudio. Once you download RStudio and you open a file, you're gonna see these 4 regions on your screen in RStudio. So you're gonna have the script section, which is where you write your code into. Then you have the console and terminal. That one will tell you all the warnings, all every time stops. You can write your code in there too and run it, but it will disappear after. Like it's not permanent. So if you want to keep the code permanent, you will have to write it in the script section. Then we have the environment and history section. You can see every time you create a data frame, every time you make up an object and in R, it will go into your environment and you'll see it listed there, which is very helpful to keep you organized. And of course, you can see the history of things that you've done. And then the bottom section, it's where you're going to see your file path and your plots and packages and help. And I'm going to go over very quickly on what those do. I found them very helpful to go and check my packages that need updates in there. And getting help, it's fantastic. So first, why do we recommend using RStudio instead of R? RStudio makes script writing a lot easier. It looks a lot nicer. And once you can click like the data frame name, in this case teachers, and the $sign, and it will already give you a list of all the variables that are in that data frame, which is fantastic. And it can also make it very convenient to view all your environment and interact with your store object. You can make you can click on this little box and you can quickly see how your data frame looks like, so you can pick into it without having to open another file. You can also see your graphs in there. So whenever you create a plot, you can make it so it renders into this view. You can also change your settings in your R and it will make it so it pops out of this section. So that's another option too. I actually just keep it there because I normally, when I'm working in a project, you have hundreds of tabs open and that's just another tab that will have open and then it gets lost. So I just keep it in the same environment. Like I was mentioning, there's multiple files in R. There's 2 main types of files that you're going to be working with. The main file is the R scripts, and you're going to see that at the end it says .r. That one just has a page where you will make your code, and unless you comment it with the hashtag, it will give you an error because it assumes that everything in that sheet is code language. So everything has to be a code. If you try to make your own comments and you say something in there, it will give you an error because that's not a function. So if you want to make a comment, you will have to use the hashtag and the pound sign at the beginning. I love using RMarkdown the most for anything when I have projects, because then I can write instructions to my RAs what they need to do next in step-by-steps when writing a script. You can also do that in the comments, but it's just more like I can actually break it down in little chunks for them to run each section at a time, and they can find errors whenever they're running. Because they normally will run the entire R script and then they're like, there's an error, I don't know what it is. I'm like, you know what it is, but it's harder to find it when you don't break it down. In the RMarkdown section, it's actually the other way than the .r scripts. In the .rmd scripts, it assumes everything is text unless it's wrapped in a chunk. And that's where that it's going to come back. And I'm going to show you what code chunks are, because all the exercises that we have for today are in RMD files. So I'm going to show you how to work with those and how you can create your own RMarkdown. To open a script, you normally will go up on the very top and files and click the type of script you want. So R script if you just want the .r file, or .rmd for an RMarkdown. There are 4 essential skills that you need to remember while you are learning to use R, and when you're teaching R, is that R is very case sensitive. So you need to keep that in mind. If you use capital letters, you need to use capital letters all the way there to call the same object or variable. So you choose one of the following for the objects and be consistent. Please be consistent. If you want everything to be capitalized, stick with it. If you want everything to be lowercase in your variable names, stick with that. More than the type of style you choose for your variable names, it's consistency that matters the most. You cannot just use an underscore once and then a dash in the other one, because your future self will regret that because you're going to get confused and you're going to be very upset with past self. So keep that in mind. And I like that. Because you cannot find the error the entire time. And I've been using art since 2017. And I've been using for quite a bit. And I've been teaching a lot. And it sucks when you spend 30 minutes or more trying to find the error, and it turned out that you just capitalized the wrong letter, or you shouldn't have done it, or it was a typo. So keep that in mind. There are a couple options for formatting the style of your variables, and I think it's important for us to go over them. There is the snake underscore case, and that one, just every word you have, you put an underscore to separate them. The camel case, just use a capital letter to separate the words. And the piercing names, that's easy. So whenever you choose, there's so many styles. This is just some of them. This is how you will normally be calling your variable names if you stick with one style. And please stick with one. Alison Horst is a wonderful artist and art scholar that you can follow on Twitter. She's amazing. She makes the best art for workshops and like your own like teaching purposes. So she has a very quick cheat sheet for the different styles for the different cases that you can use for your variable naming. And I found it very helpful. Okay, how to run your code once you have your R script. If you're using a Windows, you're gonna have to choose Control-Enter for the line of code that you choose. You do not have to select the whole. In some languages, you have to select the whole thing in order for it to run that line of code. With R, you don't have to. The cursor just have to be somewhere in that line of code that you're trying to run. And then you click Control-Enter for Windows. If you have a Mac, you're going to do the Command-Enter option. Another skill that you need to enforce is to make comments. The comments help others understand your codes and help yourself keep track of your coding. It's very, very important for you to write comments and the things that you do, no matter how simple it is. You will be surprised how many times you're like, a week from now, you're like, what was I doing here? If you are like me, it will be an hour from now. And so it's important for you to write comments for yourself and everyone that you're trying to teach this. While I was a grad student, whenever I was writing my codes, every time my PI didn't know R. So I always will have to keep in mind, like, could my PI run this code with the comments that I have in there? Will my arrays run this code with the comments I have in there? If I didn't think they could, then I was not doing a good job commenting my code. So something keep in mind. Like I will know, like I made it, but no one's in my head. I wouldn't know what it is. So please write comments if you haven't gotten that already. Install packages. To install packages, you can use the code install period packages, and then in quotation marks, you can put the name of the package in there. So in this case, Tidyverse or skimr. So once you run that once on your computer, you don't have to do it again. They get updated on a regular basis. So always keep track on the updates. Something also, like it's good for you to update things, but at the same time, be aware that if you update something, it may break your previous code. So yeah, it's nice for you to update and keep track of the changes because they usually fix mistakes on their code or errors or make things easier, but it also would mean that it may break your thing. So be aware of that. Once you install them, you need to call it. So library Tidyverse. After I installed it, then I want to use it in my script. I will have to use library and in the parentheses, the package that I'm trying to use. So packages should be loaded once per session. So if I load it now and then I close my R and then I open it even an hour later, I need to call my library again for that to work. Otherwise, it will give you errors because it cannot find the functions, because otherwise it's using base R automatically. Packages should be installed once per computer. You don't have to install it every time. I do keep those lines of codes commented out usually for my RAs or collaborators, so they know what package they need to install for them to use my scripts. But I comment it out so they don't run it every time, because it will give them a warning and be like, you already have this. Do you want me to force it and install it again? And you could say, yes, you can force and install it again, but it's just a waste of time, unnecessary. To import data sets, and R has been so great that they can incorporate a lot of different data sets. The most common one is a CSV. You call it using the read_CSV. There's also another version called read_CSV. And the difference between those two is how they handle the variable names. My go-to is read_CSV. Once you do that, you put in, I always do that. You can put the path of where your file is that you're trying to read. In this case, data dash and then the CSV. Don't forget the period CSV to the name of the CSV. It will give you an error every time. So read_CSV will read the CSV that you're trying to use, and the error is pointing to the left. That means I'm assigning that data frame a name, and I'm calling it all of that underscore data. So that's pretty much what these lines are doing. Another option that people have been using more for reproducibility is they use a package here. What it does is tell your script that to use the working directory of the file plus whatever you put in there. So it's wherever this file is, use whatever leftover path was in there, plus data, plus the name of my CSV. So it just gives the more steps or instructions on where to get the file. You can also upload Excel files. This is annoying, but it's doable. You can actually work with that. You don't have to convert everything to CSV. You can also import things directly from Excel using the package read Excel. And you can import, like read Excel will automatically import the first data sheet, but you can specify which data sheet you want to import. So I recently worked with a script that had 15 sheets inside of one Excel, but I just wanted the fourth one. So I specified to import the data set that was in the fourth sheet in my Excel file. And that way allow them to continue updating their script because CSV only allows you to just have one. So they continue updating the data while not affecting my script. So you do sometimes have to use that. You can also import SPSS files, which is also helpful for some collaborators. And in order to do that, you use the package Haven. And there's it's very similar to the read Excel and the read CSV. It's read_SAV and then the path of that document. Again, don't forget the .xls and .sav at the end of the name of your file. You can also import data files, and I do not have it here, but it's something to bring out. I'll look it up what package is that one, but you can also import data files in R. If the data files is in a working directory, you only need to specify its name. So the working directory, it's very important to keep in mind where you are, because they automatic, when you open an R file, it will automatically set your working directory to whatever that file is. So if I was working in a folder for a project, and then I open a script that's in another folder, my working directory will continue being the first file. So whenever I try to pull like I want to import something from this other folder, it will give you an error because it cannot find it because the working directory is in the first place. So something to keep that in mind. And there are some things that you can do in R. Let me put R. At the very top here, you can set your working directory and you can set it to the source file location. There's also a line of code that you can run, or you can set it to your file pane location, or you can choose your directory. And once you choose your directory, it will show in your console the code that is generated by you clicking. And you can copy that code into your script and like tell it your future self to run that every time you do it, or you can just use like the package here, like I mentioned earlier. Let's see what my slides are. Using R project sets your working directory to the folder where your project lives. So that's something very helpful in R. And if I have it in my, let me see here. You see here, there's a project that I created in there. What that's doing will automatically, it would just put together all the files that I have in my project will have its original working directory. And it just keeps it together. And you can also see in the files on the right section, whenever this loads, that you'll see all the different paths that you have access to. And that's highly recommended for each project you have to also have a project, an R project file in there. Of course, it takes forever. So I open my project. Well, all it does, it doesn't open anything. It's like empty how it is. But all it does is allows me to have access to all the files here at the bottom. So now I can go in and out of all these things a lot easier and it's handier. So that's pretty much what the project will do too. I will highly recommend you using that as much as you can. Like I mentioned earlier, on where your data set lives, I'm trying to move this slide, would be in that top corner. So every time you create an object or anything, it will show up there, and you're gonna see during the live exercises how it pops in there. That means you're uploaded. And if it's not there, you haven't assigned it to anything, so it's still like in this cloud environment. Something I found very helpful whenever I'm using different packages or just practically every time I use R is like, if you don't know how a function works and you don't know how to set it up, you can always put a question mark in front of that function rather in your console. And then on your right, it will show up the documentation for that function. So you can see what the different options are, what you're supposed to do, how you're supposed to put the call names, like it will give you some examples at the very bottom that it's very helpful because you can run them and see how that works. So whenever you get stuck and you don't know how to do it, you can always go to help and type it there and try to find it and to look for the documentation, but you can also go just ahead and put a question mark and it will give you the documentation to read. Cool. Okay, so we are done with very flash introduction to R. Now I'm going to introduce you to our Markdown. This is another image from Allison Horst, who is amazing. Okay. With RMarkdown, you can write, save, and run your code in one place. I just love RMarkdown. It's very helpful, and it can make your life so much easier to write reports, and it creates very high quality reports for anyone you're working with. So this is what the interface usually looks like. The background just changed because you can automatize how it looks in the background. But it will have the very top here with your YAML, and I'm going to walk you through each of the parts of the RMarkdown. But that's a very quick layout of whenever you create an RMarkdown file. So some examples of how you can use RMarkdown is that you can share your analysis and results with your lab in a variety of formats. You can use HTML, PDF, Word, so you can export it in many different ways. You can build interactive applications like Shiny apps through RMarkdown, which is very helpful, and hopefully you get to explore in the future. You can write journal articles. So they have actual packages like Papaja for psychology. They has it in an APA format, and it gives you a template of an article, how it looks like, and the formatting of the article. So you can write the whole article in RMarkdown. And the best thing of that is like you will have your code in there. So whenever you realize that you messed up and you should have filtered something else, or you should have used a different data set, you just need to update that one line of code with your data set when you're importing your data set, and it will generate your entire article again, even the automatized text. You can also create websites and blogs through RMarkdown, or make a slides presentations like this one. Like all my slides are done in RMarkdown. RMarkdown makes it easier for reproducibility. I do agree. Your code and narrative are in the same place, so collaborators can see what you did, why you did it, and obtain your results in the same way. It's flexible. You don't only have to use R in RMarkdown, and counterintuitive. But if you're working with collaborators that use other languages like Python, they can also have those chunks of code in Python inside of your same RMarkdown document. So you can have R and Python running at the same time in the same interface, which is amazing. Or if you're transferring from Python or another language to R now, you can always cheat a little bit and go back to your own language and put that language in your RMarkdown whenever you need to. You can alternate between text and code within the same document. So you can actually write text that is going to be exported in your document, or you can just write comments in there, and they don't necessarily have to be printed in your report, but it will be in your code. You can also visualize what your code will look like once it's needed. So like my slides, for example, right now, I could have seen the slides on the top corner and see how they look like while I was fixing the slides and the text in that. So it's all in one place and makes it so much easier. So here's a general overview of RMarkdown. Every RMarkdown has the following sections. It has the YAML at the very top, and this is where it normally will have your title, the author name. You can put the date manually, or you can automate it. So every time you need or you generate the report, it will give the date of the day that you're generating the report. You can also specify the output. Do you want a Word document, an HTML document, a PDF? Or even if do you want a table of contents, you can put a table of content in the YAML section, and it will create a table of content for you. And you can specify how many levels of your table of content you want to show in your importable. So there's everything after those three little lines over here. That means everything will be considered a text unless they are in chunks. So to write a text, stylize it, there are a couple things that you can do. You can put, if you want to bold anything, you just need to put 2 asterisks on each end of the word or the sentence, and it will make it bold. You can put 1 asterisk on each end, and that will make it italicized. So those are the basic formatting that you can do. When in terms of headers, hashtag or £, a space will make it a first level header, and 2 hashtags, 3 hashtags will make it a second and third header. And each header has its own style, how it looks like. You could change that in the background if you want with a CSS file, but originally you can just use this formatting. And they just make it so it looks bigger. You can create lists too. You can have bullet list items by having a hyphen space. Don't forget the spaces, that's important. And then you just list them, and it will automatically create a bullet point list. Something that's very helpful is that if you want a number, all you have to do is put a number, a period, and a space, and whatever your list is. It does not matter if it's 1, 2, 3, 4, 5, or 1, 4, 5, 5, or 5, 5, 5, 5, 5. It will automatically RMarkdown recognize that you're putting a number and that you want a number list. So it will create a number list correctly, no matter how you put it. So I can put 1, 1, 1, 1 for this section. I will know my second list will have 2, 2, 2, 2, just for peace of mind. But it will, in my report, it will show 1, 2, 3, 4, 5 every time. You can also have inline code, which is the best part of this, because I can write whole results section in RMarkdown, and I just put the mean of my variable blank is, and then I put the little backticks R, and whatever my function or object, like it will, everything that's in there will be considered code. So in that way, I can automatize my reports every time, because I do the same thing over and over again. So might as well make it automatic. So I just need to press a button and it will be updated every single time. And whatever used to take me 5 hours every time, it will just take like maybe a minute if my computer is slow, which is magic. So what you would do is, for example, if I'm putting in the text of my RMarkdown 2 + 2 equals, and then the backticks are, because you need to specify you're using the R language, and I put 2 + 2, in my text, it will show up the correct number, and it will show up like that, 2 + 2 equals, and the result of my function or whatever in there, which is great. Code chunks. I've been referring to code chunks all this time. So code chunks start with 3 backticks, and then the R in between those squiggly brackets, and end with 3 backsticks in here, if you can see that. So whenever those things are, whenever those 3 backticks at the beginning with the R, and then at the end 3 backticks, whenever I have them, all I'm doing is I'm telling RMarkdown that everything in between that, everything that's sandwiched in there is code, and it needs to be treated like a code, and it needs to be run like a code. So I'm expecting some sort of output out of this. So in this case, I have a code for my creating a ggplot image. So whenever I run it and I generate my report, I need it. It will create something like this, and this is all I'm gonna see. They won't see my actual code in the background. You can insert those chunks by going to the top and clicking insert, and then the language that you want to use, because you can also integrate Python or SQL or these other languages in there. And you can select it manually like that. Or you can use a keyboard shortcut. For Windows, you use Control-Alt-I, and for Mac, you use the Command-Option-I. Each chunk of code, you can specify how you want RMarkdown to deal with it. So you can say, every time I generate my report, I want you to also show me the warnings and print them for me. I normally don't, so I will make that false. I can also specify if I want any messages to be printed, if I want a specific width and height of my graph whenever I create my report, or if I want even to run. I can ignore a whole chunk if I wanted to. I just need to change the settings of that chunk. Or I can specify, don't show me the code. Sometimes my collaborators don't give anything for the code. They just want to see how pretty the graphs are, or whatever is the result. So I just hide my code and I only see the output. And you can specify that in your code chunk settings. Whenever you generate an RMarkdown, there is a special code chunk at the beginning it's the global rule for all the code chunks in your document. So in that way, I can say, for all the code chunks in my document, I want you to not give me the code, just run the outputs, just print the outputs. But then I can also go to the individual chunks in the later and be like, I actually need the code for this one, so I'm going to change individually. Even though globally I made it so all of them will now show the output, you can override that rule in the individual chunks, which is very helpful. Neating, I use neat all the time, and I forget to explain that, but that's how we export a report in RMarkdown. So you just go to the top and it says neat, and you click it, and that will just run your document entirely in RMarkdown. Here are a couple of writing reproducible code advice that you can follow. Always make sure you use the most recent version of R. This is very helpful if you are sharing your document to anyone, your RMarkdown. So what this function does, or what this chunk of code does, is that if my code needs a certain package, in this case package like library, Tidyverse, I can say, if my code requires Tidyverse, then install it. And that's helpful for my collaborators that don't have, for example, read Excel, as that's something that they don't use. So it will, instead of giving them a warning of we cannot use this because you don't have it, it will automatically install the package for them if my code needs it, which is very helpful whenever you're sharing your code. Clear your environment. That's very helpful. And it's even better if you run your same code in another computer just to check that everything is going fine. Okay. I talked a lot. We have an exercise of how to create an RMarkdown file and how it would look like. So I'm going to put you in some breakout rooms very quickly. There are instructions in the PDF that you have access to. So I'm going to put a timer for 3 minutes and then I'll call you back. Actually, I'm going to put a timer for 8 minutes. So there's 2 parts of what I want you to do that you can give it a try. And then after 8 minutes, we can come back here and we can walk through how that can work. So let's go over very quickly about the solution. I actually need to update this. That was my collaborator. So whenever you import, or whenever you create an RMarkdown file, something I forgot to mention is that it will automatically give you a template of how it will look like if you need something. So you just delete that information and then make PDF. Okay. So whenever I'm gonna show you what it looks like every time you create it. It looks something like that every time. So if you need this, you just see an example how an RMarkdown document will look like. So every time we'll show you that, which is sometimes annoying. But all you do is just delete what you don't need out of this and replace it with what you actually need the content to be. So sorry, I forgot to mention that one step that was like, it's already in there, what's going on? So just a heads up. But what I asked you was to change the title, the author, and the output. So you can just change that manually and put them in quotation mark as usual. To create a first header, you do one hashtag and the space. To create a second level, you do the same. And the list, you do it with the hyphen or the hyphen, yeah. So to need it, you just click need. You can also specify there the output that you would like to have by clicking that little arrow. So it could be the PDF, Word document, or HTML. If I wanted a Word document, I'll click on that. It will generate that. Let's see. Knitting usually takes some time. It takes more if I'm running Zoom, so I'm so sorry. But whenever it creates, it pops the document how it looks like. And you can play with more things on how to run it. I've done like beautiful reports for actual clients, and I have done reports for my collaborators on my projects. And you can all do that in RMarkdown. And it will look something like that. Of course, I told it to print all of this, so it did print all of this. But then I can send this to my collaborators and they can make comments, and it's a lot easier to integrate them. Okay. My favorite part of teaching R is teaching data wrangling and going over the different ways that you can manipulate your data set. So today we're going to use the Child Health and Development Studies data set. So that one collects the birth weight of the child, the date of birth, gestational period collected as part of a study that was run in 1961 and 1962. It also includes information about the parents, the mom and the dad, like age, education, height, weight, and whether the mom smoked or not. So the actual data set, they have a website for that, and they have an R package that you can download it, but I gave you all access to the raw data set so we can work on this exercise. Yes, I also included wherever it says data, the folder, there is a data dictionary of the variables. And now I'm including this into our workshops. It's very important for us to include data dictionary every time you work in a project, even if you're working with yourself or just like with people in your own lab or collaborators, or if you're intending this to be shared with the world. Please write a dictionary of what the variables mean. You may think your label names are intuitive, but more likely than not, they're not. Or you want to include more details about how you calculated WT, that's supposed to be weight. Like, is it in pounds? Is it in ounces? Is it in what? Instead of including it into the label name, you can actually include it in your dictionary and you can write it. Highly, highly recommend to keep track of one. However format you want to keep one, it doesn't matter. At the end of the day, I will be happy to work with a data set from a collaborator that has a dictionary, even written with a pen and pencil and sent to me as a picture, than me having to guess what each columns are supposed to be. So highly, highly recommended for you to start creating a habit if you haven't already having dictionaries for your variable names. A package that we're going to use today for the exercises, it's the Tidyverse package. So what Tidyverse is, and you may have heard already, it's a collection of packages. So it includes individual packages like string R, forecast, dplyr, and all these different packages into one, so you don't have to install them all individually every time. So you can just install and call the library Tidyverse, and it will call all these individual packages in there. Of course, the first time will tell you you don't have them, so you have to install them all. But then after that, you don't have to worry too much about it. A common thing from Tidyverse is the use of the pipe. A pipe will read each pipe. I will read each pipe as if I'm using the word then. And a pipe is this section over here. Oh, of course, I went way over. It's the percent, more than percent. That's a pipe. That's what we call a pipe. So the way I read it whenever I'm using code and whenever I'm teaching it, it's like in this chunk of code I have in front of me and that you have in front of you, I'm saying I'm going to call my data. Then I'm going to filter all the rows that have age less than 25. Then I'm going to group them by education levels, and then I'm going to summarize my data. So that's the way, like I'm telling it R to do things step by step. So that's how you would normally read this, the pipe. And this is an example for analysis on that, how it would be like. The shortcut to include your pipes, you can use Control-Shift-M for Windows and Command-Shift for Macs. So today, I'm being overly ambitious. I'm going to try to go over 12 different functions and show you how to use them and what you can do with them. And we're going to break into groups, and that we're going to be a lot shorter of time than last time. And we're going to try to run them. So what I'm going to use right now is, I always forget. So in the folder that you have access to, I'm going to use two things right now. I'm going to do live coding. That means I'm going to be showing you step by step what I'm doing using the examples RMD. So you can follow me using that RMD file. But then the exercises will come from the exercises RMD. So I'm going to show you how to use these functions, but then the exercises will show you how to, it will ask you to use these functions just in a different problem. So make sure to have those two open. I'm going to open my exercises, examples one. Okay. Can everyone see my screen well? Can you see the data updating?
Can I ask a quick question? I've never understood what the setup chunk is doing.
Yeah, so this is the global chunk. So this is what is giving all my chunks in my document a specific rule. So in my rule over here, I'm telling it to show the code for all of them. And I always forget what echo does and what these other ones. So I always just go to the menu here and then give you options to click and drop down. So it's like, okay, I want to show output only. That means I'm supposed to be using that code. So if I don't want my entire document to show my code and to only use the output, I'm just going to copy this guy into here. So whenever I need this file, it will never show the code. It will only show the output. And I don't have to go to individual chunks and do that click button and putting it into each one of them. It will give, this is the overall, the global rule for my document. I don't want to show the code, just give me the output. And you can include more things. You can say, all the figures in this document, I want them to be a 4x4. And you can specify in this global one. But then you can override that general rule if you go to the individual chunks and like, I actually want to show this specific chunk to all of you and show the code. So I want to show code and output. And then that will override my global chunk and it will show you the code. So that's what it does.
Great. So when you open a fresh document and it like has all those examples in it, it's worth keeping that first one when you get rid of their examples.
I normally do, yeah, because I normally have a common thing of what I want for the entire document. So I'm too lazy to do each one of them every single time. So I just use the global one.
Yeah, great. Thank you.
Self-efficient, but in reality, it's just laziness. Okay, let's go. Any other questions? All right. So what we're doing, yes.
Joscelin, before we go into rooms, can you just clarify to people what they should open in GitHub, like which is the exercise that they should be doing?
Yes. Again, I'm going to walk you through examples and then you're going to be put into breakout rooms. But like in this folder that you have access to, I open the example, which is what I'm walking you through. And then there's the exercises right under it. And those are the exercises that you're going to be doing with your team. And then we're going to be coming back to the solutions are also there, but like this one has what it wants you to do. It just doesn't have the code in there. It's like import the data, do this, but it doesn't tell you how, because I want you to fill those empty spaces up. And it's set to be the same formatting as the example, so they're not too different from that. They're just not asking for the same problem. Let's move this guy. Okay, so first, I'm gonna load the package like Tidyverse, because everything that we're gonna do here, for the most part, uses the package like Tidyverse. So I can move my cursor there and use command return because I'm using a Mac and run it, or I can run the chunk by clicking that little arrow looking to the right. So if you click that, it will run that specific chunk, and you'll see here. This other one over here, it tells it to run everything before that chunk. And it can be very helpful when you are in the middle of your code or at the bottom. It's like, okay, I want to run everything up to where I am right now. And then you run that chunk a specific way. So right now I'm running just the Tidyverse line of code. So I'm loading Tidyverse into my session, because you have to load your libraries every session you have for R, but you have to install it all in one. Then I want to import my CHDS6162 underscore data. That's the actual name of the file. So I'm going to use read underscore CSV, and in between the parentheses, I'm going to give it where my file is. And you can see here, it's in the folder data, and it's called all of that underscore data.csv. So that's all I've been doing here. And I'm telling whenever you read it, I want you to assign to the name data. You can call it whatever you want to, but I'm going to create an object or a data frame called data, and I imported it using read underscore CSV. So if I run that one line of code, you see in my environment, it's empty. And now whenever I assign it a name and assign it an object, it's here. And you can explore it using the square and will pop here. This is my data frame and I call it data. And it's in my environment now. You can explore your data frame like I did by clicking that. Sometimes you have huge data frames, that takes forever to open in your consoles or in your RStudio. So you can peek into your data set by saying tell the data, and it's going to show you the last rows, the last 6. The automatic is 6 rows. So we just show you the last 6 rows of your data frame. Under each label name of your columns, you can see the type of columns they are. So you can always double check that you have the right things in there. There are times that by mistake I put a character in one of my numeric columns and then I get an error all the time. It's because the moment it finds one character, it considers the entire column as character. And then you cannot do any math with it. So you can also specify how many you want to. I can specify that I want to see the last 12 rows of my data frame. And it will give me the last 12 rows. I can also specify I don't want to see the last ones. I want to see the front ones. So it will give me the first 12 rows. And you can specify however you want to go. You can also rename files. And this is important whenever you're working with someone else's data frames. You can clean your data frame names. So this one, for example, you see it over here. I have a column called, what is it? I have a column called date. And that's fine. That's not a bad name for it. But what if I want to call it date of visit? So I can use the function rename. I call my data frame, which I call data. And then I'm telling it that I want to replace the column date for a name now that says date of visit. And whenever I run that, I'm telling it to replace whatever I had in data because I'm overwriting it. Oh, it was the other way. Okay. So whenever I click head, my column that was date before, now it says date of visit. So that's how quick you can rename your different columns. You can also rename all your column names just in general by telling them to put it all in uppercase or all in lowercase. So I can use rename _with. And then I call my data frame and then I tell it to make it uppercase. To upper is the function. What that's going to do is going to make all your variable names uppercase. And the same for lowercase if you want to. So that's like quick ways that you can modify your variable names. You can also call a function a library janitor, a package janitor. I found it very helpful. So you can load the janitor package and I can use the function clean names. So that automatically will clean all my variable names and make them a specific format. So in this case, remember originally I have them, I think all in lowercase. They're right. I'm telling it to use the big camel format for my data frame. So what that does is like every word, it will uppercase it. And that's what it's doing. If I had outcome underscore something, that something will have been uppercase to the first letter. This is my screaming snake style. And that will make it all uppercase. Clean names have different styles that you can use. I do not remember them all, but you can always do the question mark clean names because that's the function. And here in your help, it will pop up the documentation for that. And in the documentation, you can see the different formats that you can play around and see which style you like the most. And there are some examples too in here that way you can do. Lower camel, upper camel, etc. So that's always very helpful. And I just brought out the cheat sheet from Allison. So another thing that I wanted to talk about was the function called separate. And this will allow you to split any non-alphanumeric value in your data frame. So if, for example, I create this data frame, I'm just creating a data frame right now. And I use, this is what it looks like, my new data frame. And this is what my column looks like, A period B, A period D, B period C. I can use the function separate. And then I'm telling it, call my data frame, then use the function separate by the column called X. Remember, that's my column name. I want whatever it's inside to be broken into two using the alphanumeric. Whenever you find an alphanumeric value, you're gonna, the first one you find, you're gonna put it in a column called WA. The second one that you find is gonna be put in the column WB. So whenever I run that, now that one column that we had except X before, it's broken into two. So it separated that one column into two. And it's now based on that alphanumeric value. You can also specify that I don't care about the first term. I just want the second one that you give me. Everything that's off after that alphanumeric value, I want you to assign it to a column called B. And that's what it will do. I'm going to create another data frame to show you something else. So if you have an A, and that happens sometimes, and you worry that that will ruin everything, actually, it doesn't. So if you see the row 4 here has an NA, and all my letters are separated by the space, which makes it part of the alphanumeric value, I'm telling it, every time you find one, assign it to the column called this way. And the second one that you find after an alphanumeric value, put it here. So now that's what happened. And you can see that the NA row that we had before, it just got separated as two NAs because that's what it is. So it didn't break anything. The opposite of separating is unite. You can use unite and create a new column that you're assigning just the new name that you want a variable. And I'm telling it to unite column 1 and 2 and separate them by a space. So unite will give me a column called new call and my word separated by the space. I could assign that whatever I want to. And why not? And that's what happened. And it just makes it so much easier. Even if I didn't want anything to be, I just want them to be together, that could happen. So whenever you're uniting, you're forcing it to be a character. So whenever I have NA, it will not unite it to one NA. Now it's Nana because it will automatically make them as characters. Okay. So now we're going to go through two functions, and then we're going to have the breakout room. The first one is select, and it's a very common one. Like the name says, allows you to select the columns that you want. So in this case, in our data frame, we have so many columns, but I just want to work with one of them. I just want to work with the gestation one. So I'm going to do data. I'm going to call my data frame. Then I'm going to select the column called gestation. And again, remember that it's case sensitive, so it has to match the name that you have in your actual data frame. So whenever I do that, I just get with one column, the one that I specified. We can also select a range of columns. You can use select the first variable to the last variable that you want. Actually, let me select that. So I will have from D raise, which was the dot raise, to the DWT, which is the dot weight. What about just the ID column and everything after? So it doesn't have to be always columns that are together. It could also be separated. So I can say I want ID column to be selected, and also everything that starts from marital all the way to the end. So you can play around with the ranges that you want, but it doesn't necessarily have to be next to each other for you to be able to select it. And you don't have to list every single one of them either. So that's what it happened. It selected my column ID and it selected everything from marital to the last column, all the way to the end. That's another function. We can also drop variables or ranges of variables by adding that minus at the beginning of that label. So I'm going to call my data frame. Then I'm going to select columns. So I'm selecting everything minus the column marital. So if we had it before, we'll see it there. And then when we tell it not to, it will be gone. So where's marital? Here, it's right there. So if I run this code now, it should be gone. That's what happened. It's gone. So I'm telling it to select everything minus something. Filter is to select rows now rather than selecting the columns. So for filter, we keep only those who we specify. Okay. So for filter, something that it took a while for me to get used to is that what I'm telling it to filter is what I'm telling it to keep, not what I'm telling it to keep out. So if I want to keep only the rows of moms that have never been married, in this case, 5 includes marital variable, then I'm going to say that have been never married. Oh yeah, never been married is 5. So I'm gonna call my data frame, and then I'm gonna filter all the rows that has a value of 5 in the marital column. That's what I'm saying here. And I'm gonna ignore this right now because we don't need it. But what that's gonna do is only gonna filter all the rows that have a value of 5 in the marital column. In this case, it's only 6 rows, so 6 moms have never been married. 4, that will only, there's no one with a marital value of 4. There, I think there's a lot with marital value of 1. There's 1,208 rows with a marital value of 1. So that's how you will filter something. And then once you filter, you normally just want to work with a certain column. So I'm going to select the column H. And that will filter my rows and select my column. So I only end up with those that have a 1 in the column H. So I can do whatever I want to with that variable or that column. You can also use filter to say things that you don't want. So instead of the equal sign that we normally use for conditionals, the exclamation mark equal is the opposite. So it's the not equal. So I can say I want to filter all the rows with a marital value that does not equal 3. And that's what I'm going to do. It's going to select everything, all the other marital values, except for the ones that are 3 are out of my data frame. You can also use this function like %in% if we want filter rows that have like different conditionals or like the fit and arrange. So for example, I want to keep all the rows that have a marital value within this range, within these values. So if it has a value of 2, if it has a value of 3, or if it has a value of 4, I want to keep them. I could have modified that to be 5. Yeah, 2 and 5 only. Then what that's going to do, it's going to filter only the rows that has either a 2 or a 5. And you can assign as many as you want in here, if I wanted to. Okay. We can create a chain of conditionals too. So in this case, in my filter, I would like to keep all the moms that were in their 20s when they delivered a child, and that were college grads who are value 5 in education. So in order to do that, I'm going to use education level equals to 5 because I want all the college grads. I want their age to be in this range from 20 to 30. And apparently I also wanted to know their height that is above 65. So this is a whole, like, I have many conditions that I would like to keep my data frame selected. And so all of these people that were selected here, which are 51, are all the ones that are above 65 in their height, above, in between 20 and 30 years old, and that were college grads. And so you can create a chain of different conditions that you will like for your filtering. You can use these different ones like more than, less than, more equal than, less equal than, or the equal and the exclamation mark equal for you to make those conditionals. If you just put 1, R will take that as you're assigning an object known as a conditional, and it will give you an error. So every time you do a conditional and you want to do equals, make sure to do it twice, equal. And there you are. Okay, perfect. So the next function that I'm going to walk you through is the function mutate. It's the one I use the most, actually. What that allows you is to make new variables or change existing ones in your data frame. So, for example, if I wanted to create a new column called decade or data decade, and I want all its values to be a set value, I can do something like this. I can call my data frame, then use the function mutate to create a new variable called data underscore decade. And I'm telling it that its content for all the rows is going to be 60. So whenever I run this, at the very end of my data frame, you should see a new column called data underscore decade, and you see that the data inside of it is 60. So you can create new columns that way, and you can actually manipulate what's in like the content of that column. You can also create a new variable based on other variables. So this is a common one too. Whenever I get international data frames and they're all in ounces or kilos or pounds, and it's like which one is what. So I can create new variables using those variables that already exist. So for example, if we use the WT underscore kilos, and I'm working with the US or the UK, and I would like them now to, like right now I only had them in ounces, so I want them to be in kilos. So the variable will be, I'm going to create a new variable called WT underscore K, because I'm specifying that this new column is going to be in kilos. And then I can make my calculation. So I'm using what was already there, which was WT. And then I'm telling it to multiply it, and that will give me the weight of the months in kilos. And if I run this, again, I should see a new column all the way to the right that has the WT underscore K. See, I created now a new column based on what I already had. Sometimes it's annoying to have too many decimals, and you can round them very easily. So you can use the function round inside of whatever calculations you were trying to make, and then tell it that I just want to use 1 decimal. Maybe I just needed 2 instead of 3. So if I run that all the way to the right, again, you should see my new data, my new column WT underscore K with only 2 decimals each. So you can make those changes doing that way. Case when, it's more like an if statement, if you've ever heard of something like that. So this will give many like conditionals. So if you find this variable, do this. If you find it with this value, this is other thing. So it's very much like that. So for example, the column marital that we have only has numbers. What if I wanted now to have the actual wording of what each number does or what each number is instead? So what I can do is I'm telling it to mutate the existing marital column that I have. I'm not creating a new one. I'm just modifying the one that I already have. And I'm telling it that case when. So whenever you find a value of 1 in my column marital, I want you to change it to the word married. If you find a value of 2, I want you to change it to legally separated, etc., etc. So whenever I run that now, if you look at the marital column, it should not have any numbers anymore. Instead, it has all my values. And it just happens that I have so many couples in here that are married, but you should be able to see another value over here. I'm not gonna give up, I'm just gonna say one value. There it is, legally separate. Okay, sometimes I want to fix an ID randomly. It's just I messed up and there's one ID that is wrong. So I can do that. So for example, if you look all the way to the left here, this is, these are my tails. If I find that, for example, it could be that this 15 over here was never supposed to be 15. It was supposed to be 19. And I messed up. Instead of changing that manually to my data frame, because it will come back next time I export my data frame from whatever I did, I'll just add it into my code to modify every time I see it. So what I'm going to do is I'm going to mutate the already existing ID column, and I'm going to tell it that whenever the ID equals 5, I want you to change it to 19. And then all this little line over here is telling you that if anything else happens, I just want you to keep whatever value was in ID. So if I run it, you should not be able to see a column 50, row 15 anymore. That should have been 19. And all the other ones should have stayed the same. Because I'm only telling it to modify that one thing. If it meets that criteria, I want you to modify it. If it doesn't, I want you to keep it how it was before. And you could have finally, like, I could have said plurality in here. And it would be like, all of them would have been 5 otherwise. So that's something else that you can do. You can use summarise to create means and standard deviation, things like that for your like summary of your data frame. So I can create a new column called gestation length mean. Of course, I'm rounding it. And I'm telling it to use a gestation mean. I calculate the mean of my gestation column. And I'm telling it to ignore all the NAs in case they show up. Otherwise, they will give me an error. And like we learned before, I wanted to round it to be only 2 decimals. So that will happen, and I created a mean for that one thing. You can change that mean into a standard deviation to SD, or you can sum them, or you can do minimum or max. It will give you that one value. We can do multiple arguments in the same like chunk. So I can create a mean column for my length, minimum length, and a max length. And you see I only changed that one function. So whenever I run them, I should have 3 columns with those 3 values. Group by allows you to do all those different calculations by grouping them by groups. So in this case, I want to calculate the mean gestation by the different values in the column smoke. So whenever I run them here, I'm going to have, these are the moms that never smoke, and this is the length of gestation. These are the moms that smoke, that used to smoke and no longer do, and this is the mean gestation. So I was able to calculate the mean for all of them based on the different groups. You can also select multiple groups inside of group by. So it could be by education level and the smoke variable. So whenever I do that, I'm going to have the mean gestation for all the moms who have an education level of 0 and that never smoke. And that's the mean. all the moms that have an education level still and smoke sometimes, and the same for the education level. The first one that we see here is just the first one that we're typing here. So I could have done the opposite and you have changed the order, but the values are the same. Across allows you to do calculations across different columns rather than you having to specify each one of them. So if we use the knowledge that we had a little bit ago, you will do something like this to create a mean for that age, month, age, station, like one by one. If I use across, I can like save my time and use, I want to summarize across these 3 columns, and I want to calculate a mean for all these 3 columns. So whenever I run them, it will give me the gestation age and parent age mean for the ones that don't smoke sometimes, or they used to smoke, they smoke during pregnancy, etc. So across can be very helpful to calculate this quick data frame. And like I was mentioning earlier, these things I was doing were not assigning to a data frame. So for you to be able to assign it to a data frame or export it to CSV or continue doing some manipulations to it or analysis, you need to assign it to something. And in this case, I normally just assign it to the name of what I'm doing to make it more clear. Sometimes you also want to export your CSV, and you can use relocate to move columns around to make people's lives easier. So I can move the age column right before the gestation column. I can also move the gestation column right after the last column. So I want to move it all the way to the end. So I can do those little modifications of my individual columns, wherever I want to position them, before I export them to a CSV, sometimes for collaboration. It just makes sense that all the age columns are next to each other, or it makes sense all the months columns are next to each other, if that will make people's lives easier. So you can use the function relocate in order to do that. And then you assign it to something and you can export it as a CSV. So if you run all these codes in here, it just will automatically move your columns, whatever you want them to. Oh, because I didn't create it to graph column. That's fine. The last function I'm going to go over is the pivot longer and pivot wider. Sometimes your things are like all in like wider. So in this case, I would like to have the age and the that age into a specific columns. Each row right now, it's each individual. I can make it so now each row, like it can be all the mom's columns put into one column instead. And now the participant will have multiple rows based on those values in the other column. And you can do the opposite too. Whenever you get a long format, you can make it wider in a way that it will make it easier for your collaborators to use, or even for you to use it later. Let me run that very quickly. I know we are running out of time. I think that one is very helpful to know. Okay. So CSV to export. So this is what it looks like right now. You see there is an age, parent age, and gestation, and there's one row for each. So if I want to pivot longer by age and parent age, this is what will happen. So now it will look like something like this. So they're all longer now, rather than what they were before, wider. So there's 2 for small. I know this is for mom, this is for dad, this is for mom, this is for dad. The longer format is usually helpful for ggplotting. So whenever you want to plug with ggplot, that would be very helpful. So those are all the functions. And you have the exercises in there to practice on your own, and you can do wonderful things with the functions that we did. They're normally all the ones that I use for the most part. We did not have any time to go into data visualization today. You do have access to that if you want to go through all the slides and the functions that you can do. But thank you so much. If you want to learn more about R and all the things that you can do, you can follow these people on Twitter that are amazing. They're always sharing packages that make your life easier. And it just makes it so much easier for you to learn and teach others. I also have a wiki with all resources that I find in Twitter. So you can have access to that and check more like courses that are online, that are free, especially free resources are there. You can also take advantage of RStudio's website, which is moving now to Porto, which is the new name of the company.